in the last class for rationals is we did non-permissible values, which are only based off the denominator, because the denominator can't equal 0. We don't care what our numerator has in it. And we did equivalent rationals, where we could multiply the top and the bottom by the same thing, or divide the top and the bottom by the same thing, and we got equivalent rationals. That's what we did last class. This class, we're doing brilliant. But it's okay. Still like you. And then today we're doing simplifying rationals. So simplifying, unlike equivalent, you can multiply or divide to make them the same, correct? Simplifying, we're just trying to make them more simple. So we're trying to take stuff out of it. Okay? We're trying to simplify. So our steps for simplifying are factor GCF the numerators and denominators. So difference of squares and GCFs, the numerators and denominators. Then our second step is to take and state our non-permissible values. Then our third step is to cancel off stuff that's the same. Okay, so we have 3 steps when simplifying. They're the same 3 steps when multiplying, so it's great. So we're going to look at example 1. It says, express the following rational expressions in simplest form, stating the non-permissible values as restrictions. Okay, so our first step always is to GCF difference of squares where possible. Okay? A is a monomial over a monomial. If there's just one term over one term, there's nothing you can do. One term over one term, there's no GCFs or difference of squares. So all you do is you write every single thing in its own brackets. So I'm going to go an equal sign along the left. Once I get a marker. So I'm still going to do an equal sign because I'm following it down. I'm saying that this equals the next one, equals the next one. They're all the same. We're just trying to make it more simple, correct? So the first has 12 and x squared. They are multiplied, correct? Is there any plus or minus sign that's sewing them together? Nope. So I can do the 12 by itself in a bracket and the x squared by itself in a bracket. So when they're monomials, you just put them in separate brackets. And then I have a 2 and an x in my denominator. So I put the 2 in a bracket and the x in a bracket. Now before I go to cancel anything off, I have to state non-permissible values and put away a phone if I have it out. So this is just like yesterday so far, except we actually simplified the numerators as well. So if I look at the denominator, I have a 2. Does a 2 create a non-permissible value? No, because that bracket does not have a variable. Would you agree? So if I want to, off to the side, I can say NPVs. Non-permissible values. And I can say 2 can't equal 0, which is a true statement, but it doesn't get me anything because there's no variable in it, so it doesn't create any problems. Correct? Then our other one is x. So we just say x can't equal 0, and I don't have to solve for anything because I'm done. It's by itself. If I plug the 0 back in, I get 2 times 0, which would make my denominator be 0. Therefore, I know I'm right. My non-permissible value is good. Now I can cancel off things if they're the same. So I have a 12 and a 2. Is there anything I can take out of those? 12 and a 2? A 2. So 12 divided by 2 is 6. And 2 divided by 2 is 1. So when I'm simplifying, I'm canceling off stuff that's the same. Then I have an x squared and an x. Can I take anything out of those? An x. Because x squared is literally just x times x. I could write it like this if I wanted to. I could write an x squared as an x times an x. Do you agree? So 1x cancels off 1x, and I'm left with 6x in the numerator over 1 times 1 times 1. Do I have to write a 1 in the denominator? No. If there was a 1 in the numerator, would I have to write it? Yes, but in the denominator I don't. So I can write 6x. And then I follow behind with my non-permissible value or my restriction. X can't equal 0. And then I box it. So that's if it's monomials. If it's monomials, if you ever have a monomial in the numerator or a monomial in the denominator, and a monomial means no plus or minus signs, you just bracket everything separately. Okay? So we'll come back to B in a second. We're going to look at C. C's denominator has a monomial, doesn't it? Do you see that? It has a monomial in the denominator. The 8 and the y have no plus or minus signs connecting them, so it's a monomial. It means one term. So I can immediately go to my, put an equal sign, immediately go to my denominator, and I can put an 8 in a bracket and a y in a bracket because it's a monomial. Is the top a monomial? Everyone's paying attention? There's some people not. In the numerator, is it a monomial? No, because there's a plus sign. We agree? So technically these are sewn together, so I can right off the bat put brackets around them because they're sewn together. Right? That plus sign, there's the 8y, there's the 2, and the plus sign sews them together. So they're stuck together. I can't pull them apart. Right? They're sewn really, really well with like titanium sewing thread. Super crazy. Okay? I can't take them apart. I can't put them in brackets, but I can do what? What could I do to the 8y plus 2? A GCF of 2. So I can take a 2 out. So I write the 2 in front. And I put an open bracket. And what's left over? 8y divided by 2 is 4y. Then plus 2 divided by 2 is not 0. It is a plus 1. So when they completely cancel off like that, when you take out a GCF, you need to put plus 1. And the reason why is when I go distribute that 2 back in, I should get what I originally had, correct? So if I put the 2 back in, just practicing, 2 times 4y is 8y, and then 2 times 1 is 2. So I got back what I had. If you don't put the plus 1, you're not going to get it back. Yeah?
Can I go to the bathroom?
Yes. Now, I can't simplify anything else more, but I have to, before I go to cancel off anything, if I can cancel, the 2 can go in its own brackets as well. Before I go to try and cancel anything off, I have to state non-permissible values. So before I go to cancel, I always have to state NPVs before you cancel. Always, always, always. So if I go and I'm like, oh, I can take a 2 out of both these. I slap my hand. I'm like, no. Must state NPVs first. Okay? Now, does the 8 have a variable with it inside that bracket? No. So is the 8 going to cause me to have any NPVs? No. The y does. So I have 2 brackets, but you only get NPVs if the bracket contains a variable. We agree? So yes, I have 2 brackets in the denominator, but only one of them has a variable, so I'm going to get 1 NPV. So I take that y, and I set it not equal to 0. And then it's done. And then I say to myself, can I cancel anything off? Now some people will look here, and they'll try and cancel the y and the y. Remember, you can't take out a monomial for a binomial. You see how this has 1 term and that is 2 terms? There's nothing the same in them. Monomials cannot cancel off binomials, and binomials cannot cancel off monomials. Okay? So the only way 4y plus 1 is getting canceled off is if there's a 4y plus 1 on the bottom. Is there? No. So that 4y plus 1 is staying for life. The only way the y is canceling is if there's a y or a y squared or a y cubed or a y4 by itself on the numerator. Is there one? No. So both of these are staying for life. So the only thing I can possibly cancel off is the 2 and the 8. So 2 divided by 2 is 1, and 8 divided by 2 is 4. So then I write this left over. 4y plus 1, technically in brackets, over 4 in brackets and y in brackets. Now I'm going to show you how we can write it without brackets in a second. But I'm writing it with brackets so that you don't cross this 4y off with that 4y. And you're like, why can't I? Because that's what you're thinking right now, because half of you would have canceled the 4y's off. The top is a 4y plus 1, right? Sewn together. It's a 4y plus 1. If I put a 2 in its place, this would be 9, this would be 8. Could I cancel? 9 and 8? No. So 4y plus 1 is sewn together. We agree? The only way 4y plus 1 is ever canceling off is in its entirety. The whole 4y plus 1 is canceling off, or nothing is canceling off. Okay? Do I have a 4y plus 1 in the denominator? No. So is this 4y plus 1 ever canceling? No. Can I cross the 4y off with this 4y? No. You can treat this like this is a sewn together human. That's its head, its body, and its feet. And this is a whole other human. You just decapitated that person if you crossed off the 4y's. Okay? The 4y plus 1 is going nowhere unless there's a 4y plus 1 in the numerator and the denominator. So I can write it without brackets. I can go 4y plus 1 over 4y. And then I say y can't equal 0. We're going to go up to B. Does B have any monomials? Are there any terms in B that have no plus or minus signs? No. There's 2 sets of brackets in the top, 2 sets of brackets in the bottom, but all of them have plus or minus signs, correct? So they're binomials. So before I go to cancel anything off, I say, can I take out a GCF? Nope. Can I factor? No, they're already factored, right? So there's nothing I can do there. So before I go to cancel anything off, I have to slap my hand and be like, did I state NPVs? Because NPVs have to be stated before you cancel. So I go to my NPVs, and I say A minus 7 can't equal 0. And I say A plus 1 can't equal 0. Make sure you're writing that down. A minus 7 can't equal 0, and A plus 1 can't equal 0. So I'm just taking my 2 denominators. Do I need my numerators when I'm stating NPVs? No, because the numerators can equal 0. That's totally fine. It's just your denominators that can't. So I add my 7 over, and I say A can't equal 7. Here I subtract my 1, and I say A can't equal negative 1. I just take my NPVs, then and only then after I take my NPVs can I cancel. So are there any of the twins matching in the top and the bottom completely? The A plus 1. There's an A plus 1 sewn together in the top. There's an A plus 1 sewn together in the bottom. So there's a twin in the top and the bottom in every way. So they can cancel off. Can I cancel the A's off of these two? No. This is an A minus 6. It's sewn together, right? The only way the A minus 6 that's sewn together is going away is if there's an A minus 6 in the denominator. Is there? No. So that bad boy's staying. What about the A minus 7 in the denominator? The only way it's going away is if there's an A minus 7 in the numerator. Is there? No. So that bad boy's staying. So you can't make the problem with these is that you guys want them more simple. So you just start canceling off things. And then it's like 7 is at the end. I'm like, what the heck? Stop canceling. Okay? So the problem is not usually the lack of canceling. The problem is usually like you're like, it must be better. So this is an A minus 6 in the top. It can't cancel off because there's no A minus 6 in the denominator. And A minus 7 is not in the numerator. So that's as good as it gets. And then we say A can't equal 7 and negative 1. And if you're like, I totally would have canceled the A's off, stop yourself. Okay? I'll get an answer of 6 7ths on the test. It's totally wrong. And I'll put it as one of the multiple choice answers because it's picked more often than the correct one. But it's totally incorrect. Okay? So when they're sewn together, that exact twin has to be in the numerator and in the denominator to cancel them off. You can't decapitate these two people and like cancel off the A's. Okay? Sewn together. Let's look at D. So the first thing I always do is GCF or difference of squares if possible, correct? D has negative x plus 7. Can I do anything to that? I could take out a negative 1 if I need to, but I don't take it out unless I have to. So I'm just going to rewrite it in brackets because it's sewn together. So I go equal sign, negative x plus 7. And like I said, I'm only taking it out if I have to. Take the negative 1 out to make a match. What's the bottom? What's the denominator? It's a difference of squares. 49 is a perfect square, x squared is a perfect square, and you have a difference sign between them, correct? So it's a difference of squares. And I told you that on the test when people get things wrong and they can't simplify, they don't simplify enough, it's often because you missed the difference of squares. Okay? So I'm going to go here, and I'm going to say, hey, square root of 49 is 7, square root of x squared is x. So I'm going to get 7 minus x. 7 plus x. Oh, my 7. Okay. 7 minus x and 7 plus x. All right. Now, before I go to cancel, I slap my hand and I say I have to state NPVs every single time. So even if I see something matched, I'm like, boom, boom. I can't do it. I can't do it until I state my NPVs. So how many NPVs am I going to have? I have 2 brackets with x's. So I'm going to have 2 NPVs. So I'm going to go 7 minus x can't equal 0, and 7 plus x can't equal 0. So here I'm going to add my x over. So I'm going to get 7 can't equal x. And this one I'm going to subtract my 7. And I'm going to get x can't equal negative 7. So I could say x can't equal plus or minus 7. And when you use the difference of squares and you separate it, you're always going to get two NPVs, one's a plus and one's a minus. Okay, now, can I cancel anything off?
Yes. Nothing by itself.
Really?
You can, because the x minus 7, or it's negative x plus 7 is the same as 7 minus 7.
Why? You're right, but why?
They're exactly the same, but just switched around.
Yeah. So the order of which they're listed doesn't matter. The sign in front of them is what matters. Correct? So the order they're listed doesn't matter. They can be listed out of order, but they have to have the correct sign in front. So if I look here, I have negative x and a positive 7. Here I have a negative x and a positive 7. So they're listed out of order, but they're actually the same. Do you see that? So the order doesn't matter, the signs in front matter. I need to drill that into your heads. The order doesn't matter, the signs in front matter. Does that make sense? So this one is negative x plus 7, this one's 7 minus x. I could relist this as negative x plus 7. I could like reorder it, and it would be the same thing, right? So this one cancels off this one. When I cancel, these are actually really big ones. These canceled lines are just slashed ones, slanted ones. So the whole numerator crossed off, so I can just not do anything. If the whole numerator cancels off, I can just write nothing. I can just write the answer. No, when the whole numerator cancels off, what am I left with? A 1. So I'm left with 1 over 7 plus x. And then I can't cancel anymore, and I say x can't equal plus or minus 7. Okay, E and F are a little harder. Often the harder ones I find you guys do better because you're like, there's stuff I have to do. So I look at E and F and I see two things sewn together by minus signs. Do you see that? Two things sewn together by minus signs? You literally can't function because you're eating. Join us. Both of you are watching.
They're ADHDing me.
Blame that.
Yes.
I agree. Okay, so we have this with a minus sign in between and this with a minus sign in between. Do you see the minus signs? Do you see how they're sewn together with the minus sign? Do you see how you're scaring me? There's two terms with a minus. You do such big eyes. I don't know what's happening. So there's a minus sign here. We have 12p squared and an 8p and a minus sign in between. So they're sewn together. Yes. So I put brackets around them. Do you see how I put brackets around them? Because they're sewn together. Everyone's following. So my first step always is, can I take out a GCF or a difference of squares? That's the very first step always. So the first step is GCF or difference of squares. Now I look here. Oh gosh. I have to stand away from it. I don't know. So I have an equal sign. In the numerator, what can I take out of the numerator?
2p.
4p. 2 was working. We just needed 1. So we can take out a 4p.
Oh,
So-
you're saying just for the numerator, not overall.
Truth.
Yeah.
Yeah. So if I take a 4p out of 12p squared, I'm left with 3p. And then a negative 8p divided by 4p is? Negative 2. Now the 4 and the p in front. The 4 and the p in front, are they attached by plus or minus signs? No. So they can go in their own brackets. A 4 in a bracket and a p in a bracket. All over. The bottom, 6p cubed minus 4p squared. 6p cubed minus 4p squared. What can I take out of the denominator? A 2 and a p squared. So I can take out a 2 and a p squared, and then I write what's left over. So 6p cubed, take out a 2p squared. 6p cubed is 3p. And then negative 4p squared. Yeah, negative 4p squared, take out a negative 2p squared, I see negative 2. And then I get excited because I'm like, dude, things match. I have done something right, right? And then I go to cross off because I'm so excited. But before I cross off, I slap my hand and I say NPVs. Now the 2 and the p squared can go in their own brackets because they have no plus or minus signs. So I actually have 2 brackets with variables. So if I have 2 brackets with variables in the denominator, I'm going to get 2 non-permissible values. So I have 2, not going to get me an NPV. I have p squared can't equal 0. And I have 3p minus 2 can't equal 0. So when I go to solve the p squared one, how do I get p by itself?
Plus 2 square divided by 3.
That one? Yes, but this one. We take the square root, and we can put a plus or minus sign in front of our square roots. So I'm going to get p can't equal plus or minus 0, which is just 0 because 0 doesn't have a sign, right? Then the next one, Kate was saying we're going to add 2 to both sides, which is true. And then we're going to divide by 3, which is also true. 3p can't equal 2. Divide by 3. Divide by 3. P can't equal 2/3. So there are my 2 NPVs. Now once I've stated my NPVs, now I can cancel things that match, right? So in the top I have 3p minus 2, which is 100% attached, correct? Does it have a twin on the bottom that matches it? Yes. If it didn't, it was staying for life, but it does, so it can cancel off.
I have a question.
Yeah.
How did the... Never mind. No, how is the 3 not squared?
Look at me, I just answer questions without answering them. You're welcome, anytime. I'm like such a good answerer. Okay, so I have p in the top, and p squared, she just answered her own question. I have a p in the top and a p squared in the bottom. What can I take out of both? A p. So this p completely cancels off and I get a 1. This p, just the squared, cancels off and I'm now left with p to the 1. What about the 4 and the 2?
2.
I can take a 2 out. 2 out of 2, I take a 1, I'm left with a 1. 4 divided by 2, I'm left with a 2. Now remember, all these slanted lines are just 1s. So in the numerator, I'm left with 2 times 1 times 1 times 1, which is 2. And in the denominator, I'm left with 1 times p times 1, which is just p. And then I have to follow behind with p can't equal 0, comma 2/3. I always state my restrictions behind. So we're going to do F in a little bit, but before we do F, I want you to do the your turn A, B, and C. Noting that A is just monomials, so they're going to go right into brackets, correct? Right into brackets. No GCF or difference of squares, right into separate brackets for A. B has a monomial as a denominator, so right into separate brackets. So try these ones out, A, B, and C. So the first one is a monomial. So what do I do when I have a monomial? Which means put them right into brackets when I get a monomial. So I'm going to go 18 and x4. Then the bottom, I'm going to go 36 in brackets, and then x7. How many brackets in the denominator have a variable? 1. You need to pay attention in rationals. It's a unit that people often find hard, and you need to be able to do well in it, because like a quarter of the diploma is this. It's like 8 questions or something like that. You need to know what you're doing. So this is not a time to like start petering out and not trying, especially when you have 6 units left and you've only done 2. Okay? So you guys gotta keep trying.
Should we be moving faster?
No, you have 4 months, 4.5 months.
Oh,
So we have 36 and x to the 7, and you're almost halfway through this one.
oh, okay.
X to the 7 can't equal 0. We take the 7th root. Honestly, if this is x, x to the 2, 3, 4, 5, 6, 7, 8, it doesn't really matter. When you take the square root, 7th root, 8th root, 10th root of 0, you get 0. So x can't equal 0, even if I took the 7th root of this. So my NPV is 0. So whenever you have like an x to the 2, 3, 4, 5, 6, 7 in a bracket by itself, your NPV is x can't equal 0. Okay? Now I look and I say, I've saved my NPVs, what can I take out of both? So I have 18 and 36, I can take an 18 out of each. 18 divided by 18 is 1, 36 divided by 18 is 2. X4 and X7, how many x's can I take out? 2, and then I can take out some more? 4. I can take 4 out. I take out the lowest amount I can take out, right? So this one has x, 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 x. This one has x, 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 7 of them, right? So I can take 4 out of this one, they cancel off, and 4 out of here, how many are left? 3. So in the numerator, I have 1 times 1 times 1, so I have 1 over 2x cubed. And then your NPVs are x can't equal what? 0. Box it. When I look at B has a monomial denominator. So whenever you have a numerator or a denominator that is a monomial, you're going to go right to it first and put that in brackets. So a 6 in brackets and a y cubed in brackets. The 6 here is just the page number. So I'm going to do this. The top is not a monomial. The top is a binomial. So I ask myself, can I take out a GCF or is it a difference of squares? Every single time whenever it's a binomial. It's not a difference of squares, but I can take out a GCF. What can I take out?
3y.
A 3y. So when I take a 3y out of 3y, what am I left with? 1. And then negative 9y squared, take out a 3y. I'm left with negative 3y. And I can check my GCF. 3y times 1 is 3y. 3y times 3y is negative 9y squared. So I know I'm right. And then the 3 and the y in the front can go in their own brackets because they're a monomial. Before I go to cancel anything off, I must do what? Slap my hand and say, did I? NPVs. So, we're close. See NPVs. Non-permissible values. So, does a 6 create me a non-permissible value? No, it doesn't have variable. Y cubed, if it's y, y squared, y cubed, y4, y5, y6, y7, whatever, it's going to be y can't equal 0. So I stated my NPVs, and now I can cancel. Now look at my numerator for a second. Every single person should be paying attention. In my numerator, I have 1 minus 3y sewn together. We agree? Is there a twin on the bottom? Is there a 1 minus 3y in the bottom? No. So no matter what happens, that 1 minus 3y is staying. Because the only way it's canceling off is if it has a twin in the denominator, which it does not, so I'm just going to write it. Then I have a 3 and a 6. Justin?
Yeah.
I have a 3 and a 6. What can I take out of the 3 and the 6? A 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And what about the y's? This one is y1, this one's y3. How many y's can I take out of both of them? 1. So this one cancels off completely. y3, take out a y, is y squared. Now in the top I'm left with 1 times 1 times 1 minus 3y. So I'll just left with 1 minus 3y. In the bottom I'm left with 2 times 1 times y squared, which is 2y squared. And then I say y can't equal 0. If you can't do this lesson, you won't be able to do multiplying or dividing as well. Because it's just the same thing over and over and over. C, what can I take out of the numerator?
3a squared.
3a squared. Because these are sewn together. So I can take out a 3a squared. And then I'm left with, if I take a 3a squared out of 3a cubed, what am I left with? An a minus 3a squared together 3a squared, 1. And then, because this is a monomial in the front, I can put it in its own brackets. The bottom, what can I take out?
12.
I would take out a
Negative.
negative 12. And then what's left behind? Negative 12a. Take out a negative 12 is just a. Could have changed the sign. And then 12 divided by negative 12 is? Minus 1. And now I see things matching. So I'm going to want to cancel, but I have to slap my hand and say
NPV.
NPVs have to happen first before I cancel. I pressed black, but it's still not. All right. So my NPV is the negative 12. Does it get me an NPV? No, because it doesn't have a variable. The a minus 1 can't equal 0. Add my 1 over. A can't equal 1. Done. Now the a minus 1s can cancel off because they're twins. They match in every single way, in letter and sign. Correct? What else can I cancel off?
You can put a 3.
You take out a 3. 3 divided by 3 is 1. A negative 12 divided by 3 is negative 4. Then we write what's left over. So I have a 1 times a squared times 1, which is just a squared. And then in the bottom, I have negative 4 times 1, which is negative 4. And then that's it. And I say a can't equal 1. Now I want you to move up and try this one out. The hint, there's a difference of squares in it. Try F. When you're done, we're going over that one on Monday.